Hello, everybody. Welcome. Also, welcome to all the online visitors who are here via live stream. So we might be hundreds of visitors here. Welcome to the Hydrogen Fuel Cell Europe. And we have a lot of great presentations of the newest technology. And the next presentation will be about the fluid management for the entire hydrogen value chain, scalable, efficient, and safe. The speaker is Head of Business Unit Fluid Transport of VOSS Fluid. It's Dr. Hans-Christian Früh. Welcome in with an applause.
Hello, everybody. And hello to you guys on the computers at home or in the office. Today I'm giving you a talk on fluid management for the entire hydrogen value chain. I will give some insights on on the company VOSS and which assets they bring in. Then we will go into some details and applications as examples for the hydrogen value chain, which will be the hydrogen storage systems and where we innovate there, and optimization approaches for the electrolyzer as a second example. So the VOSS group is essentially a foundation which has some values, and the earnings of the companies are given back to the society for different objectives like natural science, education, training, and so on. And we can divide the company in two entities, which is the VOSS Automotive as a typical automotive supplier, and the VOSS Fluid, which is basically from its core business rooted in the hydraulics applications. A quick run through the history of the company. There you can see that it all started with plumbings and fittings for home applications, and rapidly moved on to technical applications for fittings. For different applications, back up to battery thermal management, and also topics like ready-to-install lines and so on. And when we now talk about a hydrogen value chain, it all comes back to essentially the beginning of the company and the roots of the company, which are the fittings and valves, and that we will see throughout the complete presentation. So let's start with the fitting. We have here our core product, which we introduced in 2017, which is the VOSS 40 fitting system. It's a tube forming system based on stainless steel. So you see the contour. I don't know if the laser pointer works, but I can show you here. This sealing contour is formed onto the tube, and so you have just one sealing path, and it's the advantage of that product is that the assembly is torque driven, so very likely and usable for industrial applications where you want replicable manufacturing and automated manufacturing of ready-to-install lines, which me brings to the second consecutive product, which is the hydrogen guiding lines, also up to 700 bars, which can be bended to customer needs for different applications. Last year we asked us what can we add to broaden the portfolio based on fittings, and we introduced valves by acquiring the company Hypetech. And it's always good an example to show the synergies via the fitting, because here on the left side you see a check valve, and the check valve is essentially the VOSS 40 fitting, which you have seen 2 slides before, just added with the function of a valve. So we have a complete building kit and building set of valves of all kinds and functions and integration, which we now can assemble to the ready-to-install lines and fittings here. And what does this lead for us? So we have a lot of synergies. The production path of valves is essentially the same as for the fittings. So we have a the same manufacturing routes. We can combine our R&D. We look into what's happening at the customer with hydrogen and where are the needs, and we have a more holistic approach to that. And we can also validate our own solutions in our own test center, which gives a fast track to feasible solutions. So, what does this new portfolio leads to? It's essentially we can help anybody in the industry, beginning from the electrolyzers to the consumer, to the fuel cell, with fluid management solutions, which are mainly based on valves, gas handling units, our VOSS lock connection systems, sensor, and the ready-to-install lines, which are added around the fuel cell with components which are around the balance of plant of the fuel cell. So, I initially said it, I wanted to give two examples for applications. And one example is hydrogen storage systems. When we go around here in that hall, we see a lot of booths where we see pressure vessels. So what does our valve offer? They are quite lightweight, they are small and compact, and therefore crash resistant, reliable, and they're made out of stainless steel because we think that we can supply a durable product there with a long lifespan. And when switching the solenoid valve, we are drawing quite less current. Now you see the typical setup of a truck storage system there with pressure vessels and lines. And we asked ourselves, is this enough? Products like these, or could we do something more? And we looked into the combining the values of a pressure vessel with what we do as a fitting and valve producer. So how do you optimize storage systems? Typically, if you ask one of the storage pressure vessel producers, they look into reducing the capex via increasing the volumetric and gravimetric capacity. And essentially what they want to do is they want to lose less carbon fiber per kilogram stored H2. So there are several measures to optimize that. What we then did is we looked into the fitting aspect and the valve aspect. So you have here a multi-material approach where you have the so-called VOSS, the carbon fiber windings, the liner, which is normally polyamide, and you have the valve. And we understood the VOSS also as a fitting and looked as a fitting producer on that product. But the essential problem was that we don't want to do pressure vessels, so we needed partners. And we partnered with the company HRC, which is a Chinese-located producer of high-quality composite parts for automotive applications. And consequently, they stepped into also the pressure vessel business. And we joined forces there together to optimize the interfaces from the standard pressure vessel to the on-tank valve to reduce weight, to make it more lightweight, and essentially have a better overall design of a storage system. And when I talk about storage systems, it also comes to storage systems architectures where we can simplify and optimize the overall design and assembly of this via introducing, for example, a so-called gas handling unit where you have the separate components shown on the left side integrated into one little compact box. So you have less space requirements, less leakage paths, and less assembly processes, which help in the industrialization of such storage systems. Another topic I want to introduce is the topic of electrolyzers, where you have also gas handling, hydrogen handling challenges. We supply there the ready-to-install module for Inapter, for example, and I think the example of Inapter is quite good for the hydrogen industry because we need to scale up to have electrolyzers kind of everywhere where green hydrogen needs to be produced. And they have an approach from a clear distinction of classic plant engineering, which we see a lot also in hydrogen refueling station, for example, and equipment to a mass-produced product. And now we can, from our side, from VOSS, use the assets which we know from mass production of automotive products in infrastructural applications. And therefore, it's the same design and process route, like simplifications, optimization, understanding what are the requirements of a electrolyzer producer, what kind of hydrogen comes out of the stack of an electrolyzer, and what are the needs which we have to be fulfilled to address an effective product which then can be produced in masses, so that we can reduce the price of the hydrogen, of the green hydrogen, and the availability, increase the availability of green hydrogen. So that's it. I hope I have I fit into the 10 minutes of the talk. Oh, one slide forgot. An important aspect is because in our industry we have a lot of immature technologies, and we always seeking for the best solutions currently, and we try to understand what are the best and feasible solutions there. And one big asset in that case is to validate what you develop and what your products are. And luckily we have a complete test center in Lebring in Austria, where we can validate our innovations and where we can just test them in a real environment that they fulfill the requirements of the industry to have working feasible products which are scalable, efficient from the gas handling perspective, and safe for the user. Thank you very much.
Thanks a lot, Dr. Hans-Christian Früh. Is there any question from the audience to this presentation? Right now, no question. So you're invited to come to his booth. Was it D or B?
D.
D. It's D53. Can you show where D53 is?
D is over there.
Over there. D53. Thanks a lot.
Thank you very much.